All right, you are playing basketball in a European league. So remember, we got to use a metric. We can't use the negative 16 feet per second, right? Because that's standard American measurement. So we have to use um, H equals negative 9.8 meters per second, right? T squared plus V sub 0, T plus H of 0. So we have to use the negative 9.8 coefficient because that's metric. All right. You release the ball at a height of 1.9 meters. Now, I know you guys probably not used to metric, but 1 meter is about 3 feet, right? So if we have a basketball, a basketball player, you release the ball at a height of 1.9 meters. Well, just it's roughly about 6 feet, right? With an initial velocity of 8.1 meters per second. So if I multiply that by three, somewhere around 24, 25 seconds per, or 25 feet per second, right? Thank you. How many seconds until it reaches the rim, which is three, about 3 meters high or about 9 feet high. So, by the way, this is a real problem that Mrs. Abruzzo and Mrs. Meyer made up. They actually, because Mrs. Meyer is a basketball coach, she actually helped make this problem up. All right, so as always, I like to draw a picture, and I'm a phenomenal artist at this point, right? So I'm always going to emphasize that first quadrant because that's where all of the action happens, right? So I got this six, and as always, my y-axis I'm calling the height, right? And the x-axis I call the time, t. Okay, and so about 1.9 meters here. So we got this like 6 foot person right here, right? 1.9 meters. Going to throw up this basketball at, I don't know, 25 feet per second. And then it's going to hit this basketball rim. So I need let's see, a basketball rim. Here's my pole. All right. There's my basketball pole. Wow. That is pretty. And I need a backboard, right? Backboard. Now I'm looking at it right horizontally here. I don't know, backboard like this. Wow, wow, that is kind of thick. That's a big, thick backboard. That's not going to break. I'll tell you that. All right, and then I've got the basket, the rim in the basket, right? And there's my rim, and then I've got my little basket net here. Wow. Look at that. Wow. Wow. There's some artistry there. There's some talent. Okay, so basketball is going to go up and it has to hit the rim here. So something like that.
Those are smart basketball players.
Pardon me? It does seem out of proportion, doesn't it?
Hey, shoot out a 30-foot line.
It's not too bad. Trust me, I've done worse. Let's see. As always, we need. You guys are making fun of me. I don't know if I like that. Okay, so here's it's coming down a little bit. So my vertex is going to be somewhere around here, right? Vertex is going to be T comma H. All right. Now let's see if we can come up with the model, the function. So I have the H. Let's see. We actually do have the current height, right? Now, with these problems, we're putting this in the calculator anyway, so we really don't need this current height. But I'll put it in there. Then I've got my gravity coefficient, negative 9.8. I don't know what the time is, right? So here's my H. I don't know what H is. And I don't know the time when we reach H. Okay, so I'm going to leave the T variable in there, T squared plus, but we do have the velocity, don't we? What was it? Oh, initial velocity of 8.1. So here, now that's just the coefficient, 8.1. We still have to bring down the t, okay, plus, and do we have initial height somewhere? Yeah, we start at 1.9, right? That's my initial height, h of 0. So there's my equation. Now, do you want to do this manually or do you want to do it in a calculator?
Not manually.
Oh, come on, manually would be fun.
I'll do it in my calculator. You do it manually.
I did it manually for one of my Algebra 2 classes and they hated me.
Bro, every time I get a calculator, it's always freaking messed up.
Because there's 7 classes that use these. And
No, not
one of them's an AP stat. So I always tell you guys, go to your y equals, clear it out. Make sure that none of these plots are on, okay? Because the statistics course in here turns these plots on,
I don't have to.
okay? Well, yeah, I would love to, but they use it.
I'm gonna hide this.
So, okay, so to turn these off, go up there, highlight it, and hit the enter button, okay? And it turns them off. Okay? The next thing you should do,
Put a note in
go, go to your zoom key here and go to zoom standard. You could either scroll down or just hit the number 6 on your keypad, hit enter, and it defaults it back to the calculator's Cartesian graph, negative 10 to 10, right? All right. Everybody there? Cleared out your calculator? Okay, so let's go to our y equals. This is our y equals, by the way. Okay, that's our y equals. Instead of 3.05, we're hitting the y equals button. And then I'm going to put the rest of the function in there. So I'm going to put in negative 9.8, and I'm using x instead of t. So x squared plus 8.1x plus 1.9. Now, I think we're going to get pretty lucky on this in that we won't have to change our window too much, if at all. So I'm going to hit graph, and it's thinking. It's not doing anything, is it?
I think it is. It's just really small.
Oh, it is. Okay, so yeah, actually, it's actually bigger than I thought. This thing is huge, right? In fact, it's way off our calculator screen, doing something like that.
Not mine.
Okay, so you can see it that I got a blue line that's like almost right on top of the y-axis here. So my parabola is like doing something like that. Okay, so I'm really gonna expand this window. I don't know. I'm gonna go to my window key. Oh, see somebody. I thought I hit zoom standard. There it is. Is this what you guys got? Yeah. Oh, I must not have cleared out my window. Okay, so we don't really have to. I might blow this up a little bit. I don't need all this y negativity here. I don't need all this negativity in my life. So I'm going to get rid of it. I'm going to go to my window. My y, let's see, my y minimum, my negative here. I might make this negative 3. And graph it. See how it got rid of a lot of my negativity? Kind of like a muscle relaxant or something. Get it? the Razpan.
Mustard.
Let's say I might blow this. Actually, might blow this up a little bit more. I don't need to go all the way to x or y equals positive 10. Maybe I'll just go to y equals maybe 4. So I'm going to go back to my window. My y max. I don't need that whole 10. Maybe I'll just do 4. Graph it. Oh, that's pretty good. I could even shorten up my x. Maybe I'll go from, oh, I don't know, -3 to +3 for my x's. See, -3 to +3 and graph it. Wow, that's nice. I'm going to work with that. All right, so I need to find the vertex. Um, it's opening downward, so it's my maximum, right? So, oh, did I give you guys a little blue note card? I will. I'm going to grab one. Did I? Okay. So we have these note cards, handy dandy note cards that you can use on the quizzes. So let's see. I'm trying to find the max or min. I'm trying to find the max in this case. So I'm going to hit the second trace. So second trace. I'm going to go to number 3 is a min, number 4 is a max. Now you could either use your arrow key or you just go to the keypad and hit number 4. Okay. Now I want to get to the left of that vertex, and I am already. My cursor is to the left of that vertex. So I could hit enter. I'm going to go a little bit closer. Doesn't matter anywhere left of that vertex. For the left bound, hit enter. Then I'm going to use my arrow keys, bring my cursor to the right of that vertex. So they're to the right. To get the right bound, I'm going to hit enter. Then it's asking me, well, do you want me to guess where that point is? And by the calculator guessing, it's pretty accurate. So I'm going to say, yes, let me have it. And there's my vertex. 0.41, comma, 3.57. Okay. So there's my vertex. My T is 0.41, so this is 0.41. And the height is 3.57 or 3.6. Okay, so what is it asking me here? How many seconds until it reaches the hoop? 0.41. So 0.41 seconds. They're really not that hard if you, like I said, if you just drawing the picture and following the picture really helps. And because I went on a rant and rave, I'm not going to have time to do number 4. So we'll have to do number 4 tomorrow. Tell you what, I'll find something to rant and rave before, and then we can do the problem tomorrow.
Maybe we'll bring you topic ideas.
Yeah.